Let's take a look at this example. We have to determine the magnitude and direction. Okay, so direction, please look at the arrow. Okay, so my current source is going to push the current in this direction. Okay, so my current is going to flow in this way. Okay, so this is the direction of the current. Next, we're supposed to find the magnitude. Please notice that the magnitude of the currents I1 and I2 is going to be the same because these two resistors are in series. In series circuit, the current is the same in every single component. So I simply going to say that my I1 is equal to I2, and this is also equal to IS, and this is equal 35 milliamps. Okay, so this is answer for my I1 and I2. Next, we're supposed to find the voltage Vs. Voltage Vs means voltage across the current source. Okay, because this is my IS, so my Vs is the voltage between these two points, right? So what I'm going to have, I'm going to simply find the total resistance. R total is equal R1 plus R2. Okay, R1 is equal 2.4 kilo ohms plus R2, which is equal 4.6 kilo ohms. Okay, so this is equal 7 kilo ohms. Okay, we found the total resistance. So voltage is nothing else, just current times resistance. So when you're looking for Vs, this is going to be Vs is equal Is times R total, where my Is is equal 35 milliamps times R total, which is equal 7 kilo ohms. Okay, so this is equal 35 exponent 3 negative times 7 exponent 3. This is equal 245 volts. 245 volts. Okay, so this is my voltage Vs, voltage across the current source. Okay, this is my Vs. Next, I'm supposed to find V1. V1, again, I'm going to use the Ohm's law. V1 is equal I1 times R1, where I1 is equal 35 milliamps and R1 is equal 2.4 kilo ohms. 2.4 kilo ohms. Okay, so I have 35 exponent 3 negative times 2.4 exponent 3. This is equal 84 volts. Okay, so this is my voltage V1. Next, we're supposed to find power P2. Okay, so I have P2 is equal I2 to the second power times R2, where P2, okay, is simply the product of these two numbers. So I'm going to have I2, which is equal 35 milliamps to the second power times resistance R2, 4.6 kilo ohms. So P2 is equal, I have 35 exponent 3 negative to the second power times 4.6 exponent 3. This is equal 5.63 watts. 5.63 watts. Okay, so this is my power P2. Power delivered by I source. This is nothing else, just simply P total, and this is equal I source to the second power times R total. I source, we found this is equal 35 milliamps raised to the second power times R total, which is equal 7 kiloohms. So P total is equal 35 exponent 3 negative to the second power times 7 exponent 3. This is equal 8.57 watts. Okay, so let's take a look one more time what we have found, and we can write over here this is also 8.57 watts. So we found the magnitude and the direction of the currents. We found Vs, voltage across the current source. We found also V1. We found P2, and we found P total. So we can say that problem is solved.